Innovation is a journey of doubt and uncertainty, a journey that makes life better for all. At Huawei Cloud, we believe everything as a service. From a single point to a network, from one cloud to a cloud alliance. Easily extend your business globally. From one to infinity, continuous innovation and evolution, cutting-edge technology at your fingertips, turning ideas into reality on the cloud. These are what technology is about.
Hello everyone, my name is Xiaoming Yuan, professor at the Department of Mathematics, the University of Hong Kong, and the chief scientist at Huawei Cloud's Algorithm Innovation Lab. We would like to express our gratitude to the committee for selecting Huawei Cloud as a finalist for the prestigious Edelman Award. As Huawei's cloud service brand, Huawei Cloud draws on the company's over 30 years of expertise in ICT technologies, products, and solutions, and provides customers with reliable, secure, and sustainable cloud services. Huawei Cloud is committed to building the cloud foundation for an intelligent world with ubiquitous cloud and pervasive intelligence. Adhering to the approach of Think Cloud Native, Act Cloud Native, we will continuously innovate and work with our customers, partners, and developers to implement everything as a service powered by digitalization, cloud, and AI.
Make cloud ubiquitous and intelligence pervasive. Build the cloud foundation for intelligent world together. This journey of open innovation and collaborative value creation has given us an inclusive development and new breakthroughs. Together with our partners, we will journey on. Our journey of innovation will never end.
Now, I would like to invite Yuxin Zhang, CTO of Huawei Cloud, to share insight on the application of operations research within Huawei Cloud.
Huawei Cloud attaches great importance to the research and the real-world use of operations research technology. In fact, we have long realized this and positioned the optimization solver as one of the three core technologies of Huawei Cloud. At Huawei Connect 2021, we unveiled the next generation Optiverse AI solver. Optiverse is the #1 enhanced middleman benchmark of simplex LP solvers in 2022. Huawei Cloud applied operations research to many scenarios, such as airport, ports, industry parks, supply chains, logistics, and transportation. Optiverse AI solver has increased the docking rate of Shenzhen Airport by 10% and reduced airside transfer bus passenger flow by 2.6 million every year. At Tianjin Port, we help stand allocation to be complete in just 1 minute. The planning process is also 144 times faster than before. The equipment utilization rate is up 15%, while the stackyard reshuffling rate is down 20%. Overall, the port's operational efficiency has improved significantly, allowing ships to spend less time in the port. And as we know, time is money. How to maximize cloud resource utilization without compromising service quality remains a critical but challenging issue for the cloud industry. This time, Huawei Cloud's industry-leading cloud resource scheduling technology helps increase bandwidth utilization by over 30% with its innovative algorithm. The improved quality of service has translated into tenfold live streaming business growth over the past 2 years. The live service has helped the top 5 live platforms in China successfully broadcast many major events live, such as the event where EDG won the title of World Esports Champion. Operations research and solvers will never be out of date. Instead, they will inspire new value in this new age of AI. Looking ahead, Huawei Cloud will blend its vast experience in industry digitalization with operations research, AI, and industry expertise to help more business grow smarter.
Next, let me invite Yangmin Liu, CEO of Huawei Cloud Media Service, to introduce our live streaming business and its significance.
Hello, everyone. I am Liu Yangmin, Director of the Huawei Cloud Media Service Product Department. I'm happy to see the GISCO system of Huawei Cloud Live become a finalist for the 2023 France Edelman Award. Please allow me to briefly introduce our live streaming service and the pain points it addresses. Huawei Cloud Live is the accumulation of years of technical expertise. It is a one-stop solution that helps you smoothly deliver HD live content at a low latency around the world. Huawei Cloud Live is applicable for a wide range of live streaming scenarios, including sports events, online education and training, interactive entertainment such as for online influencers and gaming, and e-commerce. In general, customers now have 3 core service requirements. First, stable live streaming, which requires sufficient bandwidth redundancy to handle traffic bursts. The diversified video business is accompanied by frequent high concurrency access, resulting in complex operation and maintenance. Second, lower bandwidth costs. The explosive growth of users and their pursuit of HD tremendously drive up network bandwidth costs, which account for a huge proportion of total costs. Third, better user experience. As users now watch live videos on different devices, we need to meet the requirements of these different users and their devices. To provide premium live video, we set up a team composed of members of Cloud Video Products and experts from the Algorithm Innovation Lab, and worked with universities such as the University of Hong Kong to achieve technical breakthroughs in scheduling. Finding a balance between affordable costs, stability, and improved user experience is never easy. After conducting thorough analysis, we believe that solving the medial network scheduling problem in the 95th percentile bandwidth billing mode with optimal resource utilization and guaranteed service quality is the key to addressing all of these pain points. Our team has worked tirelessly, and their insight into the business enabled them to develop algorithms that are efficient, stable, and easy to implement. These well-designed algorithms have been implemented on our proprietary GISCO system by module. This ever-evolving system will cut costs without compromising user experience. The GISCO system has been running on live for more than 2 years. It has helped major live streaming platforms in China, such as Douyu and Huya, smoothly broadcast more than 60 major sports events live to global audience. In addition to live, we have launched low latency live and live streaming by virtual humans to further diversify our live streaming service. Low latency live elevates the live streaming experience to new heights. It reduces latency from 3 to 5 seconds to 800 milliseconds. Quasi real-time content delivery enables users to watch and interact more smoothly and fully immerse themselves in the experience. Virtual humans redefine everything you know about live streaming. With AI body and expression recognition algorithm, you can control virtual humans simply by using your own camera, achieving smooth live streaming by virtual human in real time. A virtual avatar can also be created for each streamer. Huawei Cloud hopes to provide live and innovative live streaming service to more customers both in and outside of China. We strive to provide origin, server, and acceleration service featuring high concurrency, low latency, and smooth HD. We are committed to unleashing new value for an ever-increasing number of customers around the world.
In this part, I'd like to introduce the cost-effective bandwidth allocation problems in Huawei Cloud's live streaming business. With the increase in demand for live streaming services, a major problem faced by all cloud service providers is how to allocate their bandwidth resources efficiently. I will elaborate on the unique challenges that need to be addressed to achieve a cost-effective bandwidth allocation at Huawei Cloud. To tackle these challenges, we started to develop the GISCO system in earlier 2020. I will share with you our innovative approaches to formulating mathematical models, designing high-speed algorithms, and efficient implementation techniques. As you may be aware, cost-effective bandwidth allocation problems in the live streaming business are significantly different from those in traditional operations research scenarios, such as logistic management and transportation planning. Unique challenges include the 95th percentile billing scheme by internet service providers for bandwidth resources, the huge volume of data, the requirement of fast response time, the uncertainty of the demand distribution, and the complicated network structure. These difficulties have made the development of the GISCO system extremely challenging. Firstly, ISPs charged bandwidth resources by the 95th percentile billing scheme. It has been widely adopted in cloud computing services, including the live streaming business. More specifically, this scheme measures bandwidth usage over a period, typically a month, and bills the customer based on the 95th percentile of usage during that period. For example, for a data center or a server, the bandwidth usage is collected during a month every 5 minutes, which will create 8,928 sampling points. Each of these sampling points is measured by the peak bandwidth usage in the corresponding 5 minutes interval. At the end of this month, we obtain this data and sort them in descending order. As a result, we can identify the 95th percentile bandwidth usage of this edge node in this billing cycle and compute the bandwidth cost by multiplying this number and the unit price charged by ISPs. This means that to optimize the allocation of bandwidth resources, the system must allocate resources based on the 95th percentile usage while keeping cost as low as possible. This results in a mathematical difficult objective function in its optimization model. We have rigorously proved that the optimization model with an objective function deduced from the 95th percentile billing cost is NP-hard. Secondly, the scales of the mathematical models are huge, with over 4,800 edge regions, over 2,800 edge nodes, and 8,928 bandwidth usage sampling points in a single billing cycle. The corresponding mathematical models contain more than 120 billion binary and continuous decision variables. Such a model requires more than 1 TB of memory to store its data. This means we cannot even input this model into computers without enough hardware configuration, let alone finding a good solution by genetic purpose solvers. Thirdly, one of the most critical challenges is the need to make bandwidth allocation decisions in real time, with access requests arriving sequentially and dynamically over the building period. The GISCO system needs to be able to allocate bandwidth resources in milliseconds to ensure a high-quality live streaming experience for end users. Therefore, we need to design high-speed algorithms with real-time solutions and high-performance programming. Fourthly, there exists a significant challenge in the uncertainty of the demand distribution for live streaming services. The demand can be influenced by many unpredictable factors, such as sudden breaking news or the release of a highly anticipated sports event. A sudden increase in demand may result in spikes in access requests, which may affect the bandwidth allocation dramatically. The last but not the least challenge is that the underlying network structure for live streaming services, which is an overlay network with a complicated physical and managerial structure. Designing efficient algorithms that can cater to specific applications is challenging, yet it is essential to utilize network topology analysis to identify favorable structures from the network topology that could be leveraged to design application-tailored algorithms. We developed the GISCO system to solve the aforementioned problems. In particular, I've explained our methodologies developed jointly by the University of Hong Kong and the Huawei Cloud Algorithm Innovation Lab since 2020, with respect to network topology analysis, mathematical models, the overall system architecture, high-speed algorithms, and efficient programming techniques. Our first step was to create a representation of the map of which requests from end users watching a specific video could be fulfilled by specific ISPs and services. This is a multidimensional problem, fundamentally based on where the end user is located and what they are watching. In 2020, Q1, we analyzed the network topology to identify the primary factors that contribute to the bandwidth cost in Huawei Cloud's live streaming business. Huawei Cloud's infrastructure spans across over 60 countries and encompasses 2,800 edge nodes. These edge nodes, which consist of data centers and the servers, serve as the interfaces between end users and the network. Therefore, they are responsible for most of the bandwidth cost accrued in the live streaming network. Hence, to reduce the overall bandwidth cost, it is essential to minimize the bandwidth cost incurred at edge nodes. To be more specific, there is a hierarchical infrastructure between edge nodes and end users, where all the access requests are analyzed in three principal dimensions. First, live streaming platforms. Second, channel groups differentiated by popularity. And third, edge regions. First, different service level agreements contracted between Huawei Cloud and our clients imply various queues requirements and the service prices, which may vary from the live streaming platform where an access request originates. Thus, to provide the queues differentiated services, we must recognize the originating live platform. Second, popularity of different live shows is different, and the last different levels of network infrastructure performance are required. Therefore, all live shows are classified into several channel groups according to their popularity. Third, we use the ISP and the location information to label every access request and define such a composition as an edge region. For instance, a request is labeled as CMCC Beijing if its ISP is China Mobile Communication Company and its location is Beijing. This information is crucial for bandwidth allocation because inter-ISP connections are prohibited, and the location information is used to maintain certain queues levels. Similarly, edge nodes are also identified by the ISP and the location information. For example, Figure 1 depicts an example of a live streaming channel, Client 1, Channel 1 on Huawei Cloud. In this example, there is a Client 1 access request from a Tier 1 channel in Shenzhen under CMCC. To reach an audience that could reside in any part of China, the request must be forwarded to an edge node of a matching ISP that offers acceptable queues, such as the edge node labeled CMCC Guangzhou. As shown in Figure 1, the edge node CMCC Beijing is infeasible because queues requirements are not satisfied, and the edge node CUCC Guangzhou is infeasible because of the mismatching ISP. Armed with the feasible region of how traffic could be allocated, our next step is to formulate mathematical models to analyze the problems in a quantitative, structured, and systematic way, so we can solve an optimization algorithm that will find traffic allocations to minimize cost while meeting service requirements. According to the previous analysis, the network topology is reduced to a bipartite graph, and thus the bandwidth allocation problem can be formulated as a generalized assignment problem. In this problem, we aim to assign the access request from edge regions to appropriate edge nodes such that the total bandwidth cost accrued at edge nodes is minimized. As shown in Figure 2, under the 95th percentile building scheme, bandwidth utilization on edge nodes is measured every 5 minutes, and the build bandwidth usage for a building cycle is the 95th percentile of the collected samples. There are some additional requirements we need to satisfy to have a feasible solution at this stage. First, the bandwidth capacity of each edge node is not exceeded. Second, all access requests are fulfilled. And the third, connections are built over the transmission network of a single ISP. As shown on the slide, the developed mathematical program considers all the mentioned factors. In order to solve this large-scale NP-hard problem, we needed to design a set of customized algorithms and heuristics to effectively meet the needs of the business. We were thus inspired to start to develop the GISCO system in 2020 Q2 for solving bandwidth allocation problems in live streaming business. Figure 3 depicts the architecture of the GISCO system. It consists of 5 main modules, and they are classified into a planning pipeline and a scheduling pipeline. Each module has its specific functions, models, and algorithms, and the various operations research techniques are used. Now, I will provide details of the GISCO system module by module, according to the development timeline. Besides, we will provide statistics to quantify the corresponding impact on bandwidth savings and the market share increase at each phase. In 2020 Q2, we developed the 2 modules in the planning pipeline. The traffic forecaster extensively explored machine learning techniques to estimate future requests. There are several factors that can impact the precision of the predictions. For instance, sudden booms in access requests due to unexpected events can lead to volatility and uncertainty. Moreover, privacy concerns can limit the availability of detailed historical data, which can be a challenge for training machine learning models. All these factors should be carefully monitored to ensure that the prediction precision is not compromised. The other module in the planning pipeline is the network planner, which generates queues-qualified connections between edge regions and edge nodes. For each edge region and edge node, the network planner determines if the link between them satisfies the service level agreements of the corresponding client among millions of possible connections. Various metrics, including the stream pool successful rate, the averaged store time, and the startup latency, are used to monitor the queues continuously. At the end of 2020 Q2, traffic forecaster and the network planner were deployed.
Hello, officers of the Franz Edelman Award Committee. I am Jianshu Xu, a senior product manager and financial representative of Huawei Cloud Live. To evaluate the GISCO system, we define a measurement to estimate its ability of reducing bandwidth costs. We first define the unit cost for a given quarter to be the quotient of the total fee we pay to ISPs to purchase bandwidth resources and the total amount in bandwidth of live streaming service shown in the slide. Note that it is not the procurement price from the ISPs for bandwidth resources, Instead, it measures the unit cost of providing live streaming service by bandwidth for our customers at each quarter. Therefore, if the price of network bandwidth charged by the ISPs remains unchanged, a decrease in this unit cost indicates that the GISCO system enables us to provide the same service volume at a lower bandwidth cost. We set the unit cost of 2020 Q1 as the benchmark. Concretely, we will calculate and normalize the unit cost of each quarter coherently, such that the unit cost in 2020 Q1 is 1.0. Besides, take one of our major customers as an example. Our market share was alternating between 2% and 4% at that time.
To meet the strength in time requirements of online bandwidth allocation, while also creating high-quality solutions, we have designed a scheduling pipeline consisting of 2 offline servers and 1 online server that generate allocation strategies in a cost-defined manner. From 2020 Q3 to 2021 Q1, we developed the offline server monthly level, which creates monthly allocation strategies and apprises the bandwidth cost. In this module, the static offline traffic allocation problem based on our client's expected demand for the next month at a time point is considered. It is formulated as a minimum cost network flow problem, MCNFP. The resulting MCNFP is a large-scale linear program with millions of decision variables, and it is too difficult to be solved by any genetic purpose solvers. We explored its separable structure and found that it can be efficiently solved by the combination of several algorithms, such as the generalized primal dual algorithm, the balanced augmented Lagrangian method, and extended version of the alternating direction method of multipliers, together with some classical approaches, such as the network simplex method. With the help of these state-of-the-art optimization algorithms, the MCNFP can be solved within a second for the trial dataset, which contains more than 300 edge regions and 2,000 edge nodes. Then we implement the neighborhood search algorithm, NSA, to tune the initial allocation strategies and obtain better queues, a higher multiplex rate, the higher robustness without increasing the total bandwidth cost. NSA integrates some removal and repair heuristics to improve the current solution iteratively. Specifically, we apply 2 pairs of removal and repair heuristics. The first one is to improve the multiplex rate, and the second one is to improve the robustness. From 2020 Q2 to 2021 Q3, we developed the offline server daily level. It produced daily allocation strategies and evaluates the bandwidth cost at the daily level. This module is responsible for adjusting the input allocation strategies dynamically according to changing demand patterns day by day. It applies the NSA with the same heuristic operators described to refine the allocation strategies based on updated predicted demand and the network topology. The daily level offline server outputs such refined allocation strategies and the estimated bandwidth cost. These data are extensively exploited in the online server.
At this point, the deployed modules have achieved a 17% decrease in the unit cost. Our customers have their scoring systems to evaluate the service of their cloud provider strictly, which consists of the price and marketing strategies, QoS and SLA. They determine their business scale in accordance with the scores of all bidding cloud providers. The deployed modules of the GISCO system have helped us provide live streaming services at a lower price with a higher QoS. For example, Huawei Cloud's market share of the mentioned customer increased from 6% to 12% in 2021.
From 2021 Q3 to 2022 Q1, we developed the online server and implemented online optimization techniques to allocate the traffic by determining the ratios of edge nodes at high speed. They run up to 8 million access requests in a minute, which must be handled within milliseconds. To generate online allocation strategies subject to rigid time constraints, online server creates an allocation table containing the probability that access requests from each edge region are assigned to each edge node by the traffic allocation actuator. Figure 4 describes the relationship among the GISCO system, the allocation table, and the traffic allocation actuator. The GISCO system is like the brain that generates traffic allocation strategies for the actuator to execute the traffic allocation process. The allocation table is the tangible form of traffic allocation strategies. Table 1 shows an example of the allocation table. In this example, the access request from the edge region CMCC Shenzhen will be assigned to the edge node CMCC Shenzhen with a probability of point A and to the edge node CMCC Guangzhou with a probability of point 2. Such probabilities are generated based on the results obtained by two offline solvers. With the allocation table, the traffic allocation process can be done in milliseconds, as the GISCO system only needs to execute a search algorithm to get the probabilities and a random number generation algorithm to make the final decision.
In 2022, as the GISCO system was fully put into commercial use, the unit cost was further reduced by 15%, and Huawei Cloud's market share of the mentioned customer's live streaming service grew from 18% to 20%.
As mentioned previously, the GISCO system contains 5 dependent modules, which are required to be integrated systematically from a high level. Huawei Cloud's engineers utilized advanced module programming techniques and object-oriented programming methods to achieve this goal. The concrete I/O flow of the GISCO system is summarized in Figure 5, where 5 core modules are interlinked and mutually reinforcing.
We obtained the estimated accumulated bandwidth cost saving of $49.6 million by summing the bandwidth cost saving of each quarter from 2020 Q1 to 2022 Q3. Besides, the unit cost in 2022 Q3 was 0.7, indicating a 30% bandwidth cost reduction. Moreover, our market share measured by peak bandwidth has increased from 1.5 terabits per second to 15 plus terabits per second by 2022 Q3, and to 20 plus terabits per second up to now.
The GISCO system has leveraged a range of cutting-edge technologies from operations research, particularly optimization, to revolutionize its infrastructure. This, in combination with machine learning and computer science techniques, has enabled GISCO to offer state-of-the-art solutions to the industry's most pressing problems. Innovative technologies such as network topology analysis, architecture design, mathematical models, high-speed algorithms, and efficient programming techniques have all played crucial roles in this transformation. By harnessing these technologies, the GISCO system has optimized the allocation of bandwidth resources, reduced costs, and significantly improved user satisfaction for its live streaming services. As a result, the GISCO system has become an integral part of Huawei Cloud's infrastructure, serving as a model for other companies such as China Mobile Communication Company, CMCC, to drive innovation and growth in their respective industries.
Thanks to Professor Yuan's contribution to bandwidth allocation problem, the GISCO system is able to schedule network resources efficiently. Indeed, besides to the live streaming business, the GISCO system is transportable to various media services in Huawei Cloud, such as content delivery network service, workspace, and cloud rendering service. Now let me introduce a whole picture of the GISCO system from engineering perspective. The GISCO system is an innovative and intelligent schedule system of Huawei Cloud Media Service. It comprises 3 main layers: the decision-making layer, supporting layer, and the infrastructure layer. As a cloud-native system, GISCO leverages numerous infrastructure services provided by Huawei Cloud, covering operation and management monitoring, application management, intelligent computing, and storage. At the upper layer, known as decision-making layer, various decisions are made based on different factors. First, strategic problems such as identifying the most valuable potential business that can best utilize the current bandwidth value time, are analyzed in the business assistant unit. Second, technical problems, such as analyzing resource capacity expansion and planning network resources on a monthly basis, are considered in the midterm, ranging from months to quarters. Operational problems, such as how to allocate bandwidth to each custom or edge region, are discovered on a daily basis in each scheduling unit. Immediate decisions, such as assigning any orders to any edge node, are made within minutes or seconds. A plethora of data analysis and advanced algorithms automate the decision-making from planning to execution, spanning from long-term to short-term objectives. As the supporting layer, the data used for decision-making is aggregated and categorized in the intelligent portrait unit and the intelligent forecaster unit. Models and algorithms are well maintained in the model management unit, and the results are evaluated using evaluation tools. At the infrastructure layer, all data is collected from various sources, such as real-time monitoring and other cloud services, and is processed and managed in the media data lake. The decision outcomes are transferred to task executor for prompt execution across all regional nodes.
Thank you to Informs and France Edelman Award Committee for recognizing our work. Huawei Cloud Live provides origin server and acceleration services that feature high concurrency, which is driven by data and operations research, adopts monthly resource planning, daily progressive planning, and burst traffic scheduling to achieve optimal cost points while still ensuring a premium user experience. Despite the challenges ahead, you can trust that we will continue forging a path forward. We will seek new innovations and breakthroughs in algorithm research to inspire new value for our customers and partners.